Всем привет.
Ребят, всем привет.
Взаимно.
Привет, привет, Дамир.
Коллеги, всем привет.
Привет, Павел.
I think we can start.
Хорошо. Друзья, с вами Иван Хворов, продукт-онер программы ММА. Я короткую интро дам, буквально 5 минут, потом прошу еще Мишу пару слов сказать, и мы передадим виртуальный микрофон нашему профессору Алексу Скотту. Первый организационный момент. Вы находитесь в Zoom-трансляции, в которой вы можете выбирать, какой язык вам удобен. У нас есть профессор, который преподает на английском, есть переводчик, который переводит на русский язык. Вам достаточно просто выбрать опцию «Перевод» или «Interpretation» в меню Zoom и выбрать тот язык, который вам нужен. Соответственно, если вы хотите задать вопрос на английском, вы переключаетесь на English и задаете его на английском. Если вы хотите задать на русском, не проблема, вы задаете на русском. Переводчик Алексу переводит соответствующий канал английский. Владимир, спасибо Владимиру за работу с нами сегодня. И он, соответственно, получает вопрос. Поэтому у нас таким образом настроена коммуникация и восприятие лекции. Второй момент, это был даже нулевой момент. Первый момент. Это новый относительно, то есть не новый в плане мы онлайн делаем очень много, но новый в плане degree-программа, которая работает длительное время в онлайне. Поэтому, как я вам уже говорил, обратная связь для нас очень важна. В том плане, что вы помогаете нам делать программу лучше. И ту обратную связь, которую вы нам уже давали в большом количестве, и в формах обратной связи, в личных беседах, мы все интерпретируем. Если вы не видите прямо моментальные изменения, это означает, что либо мы их делаем, либо это конкретно какой-то кусок обратной связи не отражает мнение какого-то критически для нас важного массы людей. В общем, поинт, который хотел сделать, давайте нам обратную связь, либо пишите ее, оформляйте, либо потом в формах обратной связи. Мы по-прежнему очень этого хотим. Второе. Онлайн-занятия предполагают ваше присутствие с включенными камерами. Есть регламент в школе, что посещение является частью оценки и прочее, но мы здесь с вами взрослые люди, которые пришли учиться и сами этого хотим, поэтому я призову вас это делать по другому соображению. Это просто очень приятно, и это уважение к лектору. Не всегда он прям следит за камерами и прочее, но это просто, я сам, как иногда работающий в онлайне, знаю, что это просто очень приятно, когда ты видишь лица людей, они реагируют на тебя. Вы не обязаны всегда выглядеть идеально в камере, но, пожалуйста, будьте с включенной камерой. И третье. Мы стремимся сделать так, в том числе по следам обратной связи от вас, чтобы занятия носили для вас практически прикладной характер, в идеале перекладывались в деятельность в проектах. Там немножко разные темпы иногда у проекта бывают, но мы это делаем. И чтобы вы понимали, зачем те куски информации, которые мы вам даем, те блоки информации, зачем вам их даем. И по этому поводу пригласил Мишу Недика, нашего академического директора, чтобы он немножко дал вам картинку, что мы сейчас будет происходить в плане занятий и какие это имеет для нас, для вас в первую очередь, как для наших студентов, последствия в плане проектов, как это перекладывается в практическое применение знаний, чем мы сейчас будем заниматься в ближайшие, полтора-два месяца у нас будет, полтора месяца, грубо говоря, онлайна. Вот. И, кстати, вижу уже сообщения, те, у кого... у Вити Дьякова ник отличается. По возможности переименовывайте себя в фамилию, имя, так просто комфортнее для всех. В идеале переименуйтесь на латинском, напишите там Евгений Сторожук по-латински, чтобы было удобно лектору, но это можно в процессе сделать. У меня все, спасибо большое. Миша, передаю тебе слово.
Спасибо, Ваня. Надеюсь, что меня хорошо слышно. Подтвердите, пожалуйста. Супер. Огромное спасибо. Очень приятно всех видеть. Мы возвращаемся в таком онлайн-формате, как Ваня говорил, в общем-то, у нас для школы Сколково формат новый, но, в принципе, он достаточно опробованный в различных вариантах такой ММА-программы. И мы сегодня практически проводим с этим форматом в данной аудитории эксперимент. Поэтому, немножко повторяясь на Ванин запрос про обратную связь, сразу постарайтесь дать обратную связь, что сработало, что не сработало. Мы постараемся максимально на основе обратной связи сегодня максимально подправить данный формат под ваши запросы. То есть вот такая просьба. С точки зрения содержания, ну, вспомним, где мы, в принципе, находимся. Мы прошли фактически то, что у нас называлось в информации о программе первый модуль, который состоял фактически из 2 курсов. Первый курс это был Юрий с некоторым, так бы, с некоторым моим участием. И там фактически шла речь о принятии решений, роли аналитики в принятии решений. И второй модуль был сфокусирован на управлении проектами с такой как бы концептуальной точки зрения, а также разборе некоторых функциональных областей, который, когда и данный разбор, в принципе, был предназначен для того, чтобы выровнять терминологический уровень понимания в классе. Что-то там понравилось, что-то не понравилось, но в целом вот мы как бы это закончили. То есть мы сейчас будем предполагать, что, в принципе, все находятся как бы на одной странице с точки зрения терминологии вот, по функциональных областях и примерно понимают тоже, как мы собираемся управлять проектами. Теперь, с точки зрения того, что сейчас придет, я хотел бы показать частичную карту, она не полная, но она, в принципе, описывает достаточно детально то, что происходит в этом модуле втором, и значит, те темы, которые у нас грядут в третьем. То есть давайте я сейчас его зашерю. Надеюсь, все это сработает. Вот, так. Все видно? Подтвердите, пожалуйста. Хорошо. Значит, смотрите, то есть сейчас у нас будет происходить фактически 2 курса. Они будут в последовательности. Первый курс наш профессор Александр Скотт, который будет рассказывать о процессе как бы сбора и обработки данных. А при этом, естественно, мы знаем, что данные собираются, мы, в принципе, знаем, что они там нужны для отчетности и так далее. В данном курсе будет особенно заострено значит, то, как данные используются для анализа. То есть как бы связка с аналитикой, в смысле, что нужно сделать с данными, чтобы они могли быть использованы для аналитики. Где это, в принципе, нужно вам в проектах? Есть, как бы, так сказать, диапазон оценок, но в целом объем именно вот работы с данными, собственно, такие инженерные аспекты, они в реальных проектах могут занимать 90% легко. И те из вас, наверняка, кто как бы имел какие-то касания с этим, для себя уже нашли, что, может быть, на это очень похоже. Зависит от частоты данных, естественно. То есть у Александра будут, в принципе, затронуты темы, которые связаны с оценкой качества данных, того, что мы можем с этим сделать, и того, как мы можем подготовить данные для, вот, собственно, моделирования. Если мы смотрим по таймлайну, с левой стороны вот нашего экрана, где я показываю, там, в принципе, вот мы начинаем сегодня с процесса Data Science, процесса Data Mining, и плавно переходим, во-первых, у нас там будет для кого-то из вас проектный метап, где вы, в принципе, можете сразу начинать задавать вопросы, как этот процесс связан с вашим проектом. Да, потом мы перейдем, собственно, к типичным источникам данных и процессу извлечения данных из баз. Потом переходим к визуализации, описанию, и потихонечку подходим к тому, что, собственно, как эта работа с данными происходит. При этом мы, естественно, будем все это описывать не в теории, а это будет с практическими упражнениями. И сегодня, в частности, тоже будут такие упражнения, то есть будьте готовы, в какой-то момент вас переведут в breakout rooms. Александр при этом более детально про это расскажет. Второй митап, он происходит, как мы говорили, 29-го, тоже показан в средней колонке. И перед этим у вас будет еще один спикер, это Дмитрий Гуриев, с которым, наверное, кто-то из вас уже знаком. Мы с ним довольно уже, долго работаем, как бы уже, относительно, полгода, в принципе, сотрудничаем по разным темам. Дмитрий вам расскажет про вопросы управления данными в организации на, так сказать, в хорошем таком, как бы вот, хорошем сетапе. После того, как Александр закончит 8 февраля такой рабочей сессии, мы перейдем к, собственно, курсу, который будет рассматривать аналитические инструменты. То есть, как бы, прогрессия какая, что вы уже посмотрите что можно сделать данными, как провести аудит, пообсуждаете это, и можно будет перейти, собственно, к такому более углубленному моделированию. Мы начнем как бы с описания, в принципе, вот таких основных процессов аналитики, процессов внедрения аналитики. Рассмотрим довольно глубоко построение предиктивных моделей, в том числе таких более сложных моделей, естественно, на практических примерах. Поговорим про описательную аналитику и ее типичные use cases. Ну и закроем модуль двумя очными днями 26 и 27 февраля, где у нас, в частности, будет кусочек по проектной работе, а также будут два очень важных блока, связанных с диагностической аналитикой, то есть как бы установление причинно-следственных связей. Это очень быстро развивающаяся область, и она, в принципе, в грядущем будет крайне полезна для принятия решений и для построения модели, в принципе, развития бизнеса. Ну и, наконец, 27-го мы закончим проработкой типичных use cases и инструментов прескриптивной аналитики. И если смотреть назад, то у нас, в принципе, какие-то элементы этих моделей уже мы обсуждали немножко. В частности, мы обсуждали прескриптивные модели в модуле Юрия Левина. Вы это немножко видели. Мы это рассмотрим глубже с примерами на таких реальных библиотеках API, то есть уже не в Excel. Да, мы перейдем на более серьезный уровень. И, в принципе, будем также говорить о том, как это все операционализировать и запустить в продакшн. То есть вот это закроет модуль 2. В модуле 3 у нас два 100% очных курса. Первый курс – это по стратегии и управлению изменениями 17-20 марта. И второй курс – это 14-18 апреля по этике и безопасности в искусственном интеллекте больших данных. То есть вот, в принципе, вот это вот ближайший наш таймлайн. А после этого мы переходим там уже дальше к модулю по искусственному интеллекту, машинному обучению большим данным и управлению моделями машинного обучения. И заканчиваем, соответственно, функциональным модулем с 4 курсами в областях, которые мы довольно детально обсуждали. То есть вот где мы в программе. Если, коллеги, есть какие-то вопросы, давайте можно немножко быстренько, наверное, задать на 5 минут, если необходимо. Если нет, тогда могу передать слово Александру. Хорошо, коллеги, я так слышу, что, в принципе, вопросов вроде нет. Если кто-то вот хочет задать, я, наверное, еще могу остаться какое-то время, в комментариях могу ответить на какие-то вопросы, то есть поприсутствую пока. Но, в принципе, мое удовольствие тогда представить нашего профессора Александра Скоттера. Мы с Александром очень долго работали совместно в контексте вот именно программ по аналитике и искусственному интеллекту в Канаде, в Торонто. И, значит, не только таких degree-программ, но и программ корпоративного обучения. То есть очень, очень давно знакомый Александр. У нас как бы, значит, профессор такой, как бы он индустриальный, да, то есть то, что у нас в терминологии Сколково называется профессор практики. И, в принципе, во всех его вот лекциях, во всех его занятиях вы увидите абсолютно такую практическую точку зрения на вот этот процесс. То есть он все примеры из реальной жизни абсолютно. И, соответственно, как я немножко повторюсь, если вы видите, что, значит, как бы вам хочется немножко видеть какого-то больше там интерактива определенного рода, то есть тоже давайте обратную связь, мы постараемся с Александром это обсудить и включить соответствующие элементы в нашу работу. Спасибо, коллеги. Александр, ваше слово.
Thanks very much. I'm very excited to be here. Thank you for having me. So let's talk about what we're going to do today. I want to tell you a little bit about myself. I'll give you a sense for my background, why I'm here, what I hope to bring to the course for all of you. We'll talk about the course itself, so what to expect over the next 8 sessions together. And then we're actually going to jump right into doing some of the data science work today. So today we're going to program in Python. We're going to work with data. We're going to do some data exploration. Don't worry, I'll walk you through all of it. We'll start from the very, very basics with Python, and we'll get you started right from scratch. Lots of exciting stuff to work on together. A little bit about me. So my name's Alex Scott. I live in Toronto in Canada. This is my first time teaching at Skolkova, so I'm very excited to be here. I'm very glad Mikhail and Yuri decided to bring me along. Super exciting. I do teach in Toronto as well. So I teach at Queen's University in Kingston, Ontario. But that's only part of what I do. My day job, I've been working in analytics for quite a long time. So right now I work at an organization called Borealis AI. It's the artificial intelligence research division of our largest bank here in Canada. It's called the Royal Bank of Canada. At Borealis, I act as a translator in between the business line itself and many of our machine learning researchers. So we hire PhD machine learning researchers, brilliant minds, brilliant programmers, and we use them to solve some of RBC's biggest data science problems, biggest machine learning problems. It's a very exciting place to be. Just for a little bit of context, RBC has about 14 million customers. They make about $12 billion in profit a year. So it's a very big organization. It has lots and lots of data, lots of opportunity, but it's also very old. It's over 150 years old. And that means that our data is absolutely terrible. It's old, it's been stored in ways that aren't useful for analysis. And it's one of the big reasons why some of the material we're going to cover in this course is so important. Mikhail touched on just how long it takes to get good data, because it normally starts in a pretty messy form. Sometimes it's hard to even find in the first place. So we will talk about all of that. We'll give you the tools you need to think through how to get that data, how to clean it up, how to understand what good data even is, because it's not always obvious. Before my time at Borealis, I worked at a few other banks. So I worked at another big Canadian bank. I led a data science team. I've solved data science problems that way. And the rest of my career has been in management consulting. In my time in management consulting, I've been able to travel around the world and do analytics work for public sector organizations like governments, other financial institutions, insurance companies across Canada, the United States, Australia, the UK. So lots of practical experience here. I've been really fortunate to work in many of the different departments of these organizations. So I can bring examples from marketing, from risk. The banks have treasury departments where they handle all of the money, figure out where to lend to, the credit space, deposit spaces. So lots of practical experience here. And I think this is really important when we talk about a graduate program like the MMA. Folks like yourselves in an MMA program are going to be the data science leaders of tomorrow at your organizations. You're going to be the ones solving data science problems, bringing on data scientists, perhaps becoming data scientists, some of you, citizen data scientists. And so throughout the course, we'll always balance the academic side of things, the theory you need, with practice. Every new technical concept we introduce, I'll then do a live demonstration in Python, and you'll get a chance at the end of the sessions to practice yourself. So we'll put together some exercises, we'll break into teams, and you'll actually write some code and see some results. So I'm very, very excited about that. A couple of things I want to cover right off the bat, because I know programming is intimidating. We're going to be starting from the basics. My first demonstration, I will open up the very first Jupyter notebook for you, and we'll write some very, very basic lines of code. I do not intend to make any of you great programmers. You don't need to become an excellent programmer to be successful in the course. I understand some of you will not want to program. So all of the technical concepts we introduce will have what I like to call a cheat sheet that goes along with it. And this is all of the code you need to do an analysis or clean some data. You'll be able to, as the course progresses, take that code and modify it to suit your purpose. Modify it for another data set, for different types of variables, for different techniques. So don't be intimidated. We're going to work through it all together. We're going to get lots of practice. What I will say is that if you want to get good at programming, you have to write it yourself. You have to get into the weeds, try to write some code. It's going to be frustrating. You're going to get errors. Things aren't going to work, but solving those problems, that's what's going to make you much faster and much better at this. And we'll work through all of that together. In terms of what we'll be doing for the course, today is all about data exploration. So we'll actually work with some data sets today. They'll be dirty. You'll have to clean them up, get them into a format that's useful. In the next class next week, we'll introduce SQL. SQL is a database querying language, and it's really the key to pulling data out of organizations. Almost all data is stored in a database somewhere. You're going to have to get it out. SQL is one of the most important languages for data scientists. We'll also talk about database design. How is a database structured in an efficient way to make sure that you can access that data, to make sure that that data is reliable and clean. We'll then move on to talking a little bit about data visualizations, a little bit of dashboarding. I'll introduce Tableau, which is optional for the course, but I'll show you a little bit of Tableau. Tableau is a very popular data visualization tool where I work. It's not the only one, but it's very, very popular, very powerful. And we'll talk about why it's so important and how it can really transform how your organization functions, how your organization does reporting, and how you can free up time from people who might spend their entire days just doing reporting. We then have Dimitri joining us to do a guest lecture on practical data management. I'm working with Dimitri now on some of that content, but I'm very excited to have him here. He spent a lot of time over the last year or two thinking about data management best practices at his own organization, and he'll be able to share some of that with you, which is great. We're then going to move into, over the next 2 or 3 classes, what it means to have data good enough to build a predictive model. Ultimately, that's where we all want to go, right? We want to use machine learning. We want to make predictions. We want to try and understand the future so we can make better decisions today. Unfortunately, if you have bad data, those predictive models don't work very well. So we need to figure out what it means to prepare your data well enough up front that the output of your predictive models are reliable. To do that, we're going to build some very simple predictive models, one called a linear regression, one of the simplest, most understandable predictive models. And we're going to look at the output from those models to understand what's gone wrong, what's wrong in the data, what can be cleaned up. And we'll talk about what can be fixed versus what can't be, what might just be a characteristic of your data that can't be resolved. And what does that mean for the accuracy of your model going forward? Our last class together will be focused on pulling on everything we've done together and doing some practice problems. So we're going to work on sort of mini case study style problems in our teams. At the same time, I'll come meet with all of the teams and we'll have a bit of a breakout around your final projects. I'll talk a little bit more about assessments for the course. 3 ways we're going to do assessments in the course. The first one is just class participation. I'd love to hear from all of you what's important, what's working, what do you need more help with? So please feel free to ask questions, put your hand up anytime. The more we interact, the more questions you have, the better the course experience will be for you. I'm happy to tailor the content to better fit what you need. Number 2 is we'll have a team assignment that we'll release very soon. This will be based on what we learn in class, and it will be sort of a direct application of what you've learned to another problem. So we'll get a chance to practice some of that Python, interpret some of that output, and the focus will be heavily on interpreting output, understanding how something worked or didn't, and what you're going to do to fix that. And then the last piece is a final team project. The final team project you have two options for. The first is you can do a case study style project with your team where you go out and source data, perhaps from your organization. You use some techniques in the class and you solve a business problem. I'll release more details about this later, but it's a great way of bringing some of these techniques back to your organization. So if you wanted to collect some data, clean it up, produce a dashboard, that's great. If you want to clean it up, build a very simple predictive model, bring that back and use it at work, it's great. We'll talk about all the different options in that space. The second option is you can do a data audit for your capstone projects. I want to make sure that as you work through your capstone, you're setting yourselves up for success. And so Mikhail and I have discussed allowing you to do part of your capstone project as the final project for this course. The data audit would basically be your opportunity to collect the data, explore it, clean it up, produce some very simple analysis. We'll talk about some of the summary statistics you can produce, some simple visualizations, things of that sort. So two options in that space. We'll talk a little bit more about those as the course progresses. Lots of time to take those on and get them started. But that's what we'll be doing for course assessment. Otherwise, most of what we do will be together in this class. And this is where we'll be doing most of our practice. One last thing I want to talk about before I pause for questions is materials for the course. So I will be posting materials on Canvas before all of our sessions together. There will always be slides, and they'll be translated in both English and Russian. There will be those cheat sheets I spoke of. They are saved in Jupyter Notebooks, which is the format we use to program in Python. And they'll have a little bit of a description, they'll have some code, and they'll have some output that we'll work through together in class. To open those, you will need a piece of software called Anaconda. I'll put a link to that in the chat. If you don't have it yet, don't worry. We'll take lots of breaks today. You'll have a chance to download it and get it ready. And I'll show you once it's installed, how to start working with it. Like I said, we'll be starting right from the basics there. Of course, I'll be giving you data to work with as well. So you'll need Microsoft Excel or some sort of tool like that, so you can take a look at the data that I'm posting. And if you're interested in spending some time in Tableau, there are student editions of Tableau that you can get for free for 6 months or 12 months. And I'll also post either in the chat or on the portal somewhere where you can get that material for free. There is also for Tableau a version called Tableau Public. This is free forever, but you can only save your dashboards online in the cloud. I'm perfectly okay with that. You should just be aware that if you're doing work for your organization, it's private data or something to that effect, maybe not the best idea to post it on the internet. Okay, let me pause here before I go on. Any questions about me, about the course, about the assessments, anything we should talk about before we move on? Yes, go ahead.
Hi, very nice to meet you.
Nice to meet you.
One technical question. Is there any difference between using Mac or using PC?
There are differences, but they are not really meaningful. So I'll talk a little bit about the syntax changes. Both Mac and PC work perfectly well for Python, for SQL, and for R. We're not going to be using R, but it's the next programming language. So perfectly fine, either operating system.
Okay, thanks. Thanks.
Any other questions, thoughts, concerns? Okay, well then let's talk about what we're going to do today. And to get started, let's talk about how we're going to structure our classes. I want to make sure that we have lots of opportunity to take breaks, recharge. I wish I could be there in Moscow with you all for all of these courses, but we're stuck on Zoom. So let's make sure we can take some time to recharge in between sessions. I promise I won't talk at you for hours at a time. Take breaks, we'll do exercises. For every course, for every class, what we will do is I will lecture for a little bit. So I'll walk through my slides, I'll tell you some stories, we'll talk about the theory. We'll take a break, and then I'll do live demonstrations. Those demonstrations will be in Python. I'll walk you through writing the code, interpreting the output, things of that sort. And then at the end of class, we'll break into our teams and we'll work on practice problems, exercises. You'll work through some of the cheat sheets. I like putting people in teams for these because it's a great way to learn from each other. You're all going to get different things out of the course. You'll be able to bring it all together, solve those problems together. I recommend that one person on the team shares their screen so you can all see what's happening. You can work through these things together. And of course, I will be here for all of those practice problems. So when you're in your breakout rooms in Zoom, you'll have an option to ask for help with the little hand sign. If you ask for help, I will come join you in the breakout room. Vladimir will join us to help translate, and we'll work through those problems together. I'll help you out. We can talk, we can get to know one another. It's a really great way for me to get to know all of you a little bit better, because instead of having 35 people on the screen, there's only going to be 5 or 6 of you. So we can talk a little bit more intimately, which I think is really great. The next week, I will try and take up some of those practice problems so you can see how I would approach them from scratch. So I'll give you the solutions to those. We'll work through them together at the beginning of class, and then we'll rinse and repeat. We'll do exercises together. We'll do a little bit of lecture, and of course, we'll talk about some of the assessments for the course as the course progresses. I believe Margarita has already created some teams for you. I don't know if she's told you what those teams are yet, but you will certainly find out today when we do our breakouts a little bit later in the session. Before we jump into the slides, I do want to talk about one thing, which is Python versus R versus SQL. This is one of the first questions I get when I show up for new courses. People always ask, why Python or why R? What's the difference? So I will give you my thinking on this. There are many different schools of thought, but Python, I think, is the most popular data science language right now. Certainly the most popular in industry. If you're talking about doing analysis, getting it into production, actually using output from a model at work, Python's the best for that. Python has relatively few, but very large packages. Packages are ways that we add additional functionality into Python. So some of you may have heard, for example, scikit-learn or PyTorch. These are examples of packages that you install in Python, and they allow you to build very, very complex models. Neural networks, deep learning models, etc. R, on the other hand, has very, very many small packages. They're very, very specific. There's generally a little bit less code to write in R because those packages are so specific, but it's far less good at production systems than Python. In this course, we're going to be focusing on Python. All of the material will be in Python. If you're interested in R, if you want to learn R, if R is popular at your organization, just let me know. I'll send you all of the material in R as well. So I have all of the cheat sheets built in R, so you can learn both if you'd like to. I recommend, if you've never programmed before, start with just one. Don't try and do both. Once you learn your first programming language, the rest become much easier. Don't try and do two at the same time if you've never done this before. And the last one, SQL. SQL is not a data science language per se. You can't build predictive models with SQL. It's all about data manipulation. It's about pulling data out of databases. It's about getting access to data. Again, we'll focus on SQL for one session in the course. Once you learn a little bit of basic SQL, it's very easy to apply in all sorts of different places. Okay, one last pause for questions, comments, anything else we should talk about. All right, well, I'm sure you will have more questions later. Once we start getting into the material, there's lots to talk about. Until then, before we get started, I'm going to suggest we just take a 10-minute break, grab some coffee or tea, have a bio break, and we'll meet back here in exactly 10 minutes, and then we'll jump into some of the PowerPoint. Sound good? Excellent. We'll see you in 10 minutes. Okay, we have some answers coming through here. So I'm going to share my screen so you can see this here. And I'm really liking some of these answers that are coming through. Analyzing data, getting the solutions. I saw one about using data to make management decisions. These are all really, really great answers. Digging into data to find complex solutions to complex problems. Excellent, excellent. The reason I do this is because analytics has become a bit of a buzzword. Everyone wants to do analytics now. Everyone wants machine learning. Everyone wants artificial intelligence. And it's important to level set on what analytics is. And it's especially important to remember that some organizations that are early in their analytics career don't need artificial intelligence, don't need very complex models. Sometimes the first data science solutions you take on are actually kind of easy. Sometimes it's really just getting your data in a format that's workable. And then you move on to taking on more and more complex tasks. So I like a lot of what you said. I'm going to give you a definition that I like, and then we'll talk about some of the details of what you posted. I like to say that analytics is any time you're using data to draw insights or take action to solve a business problem. And I think you all captured that fairly well in what we just did. But I saw some other pieces in here that were really important, which were around making management decisions. And I think that's absolutely true. When I first started teaching in the MMA 6 years ago, analytics was still very new. Today, everyone's using analytics. Many people are using machine learning. And so it's not just a competitive advantage to be good at this, but now it's sort of a requirement. Where I work, at one of Canada's biggest banks, we only have 5 banks in Canada, for context. 30 million people, 5 banks, that's really it. So it's very, very competitive. And really the only way to grow as a bank is to steal customers from the other banks, because everyone here has a bank account. So the best way for us to compete is to know more about our customers than anyone else, to be excellent at data management, to be excellent at analytics, because otherwise people are going to steal them from us. It's a requirement. It's a base requirement. And then you can move on to competitive advantage. So I really like this lens of making management decisions. And folks like you, who are going to be not only the leaders, but the analytics leaders of the future, are going to need to keep that in mind. How do you make better data-driven decisions instead of what we might call the gut feel decision? What we think we should do instead of what we know we should do based on what the data tells us. So I really, really like that. I'm going to jump into my PowerPoint here, and we'll talk about a few more things. Okay, a few more definitions. We talked about what analytics is, but there are a few subsets of analytics. One of those is artificial intelligence. This is, I think, the biggest buzzword of the year. Everyone wants artificial intelligence. Put very simply, artificial intelligence is any system that acts like a human, that tries to understand humans, that tries to learn like a human, that interacts with humans. So if you have an iPhone like me, Siri is AI. If you have an Android, that might be Google Now, that's AI. Amazon's Alexa. AI is very powerful, but there's still a long way to go with artificial intelligence. For example, not that long ago, Microsoft introduced an artificial intelligence Twitter bot. So it lived on Twitter and you could interact with it. You could tweet at this bot and it would tweet back at you and you could have conversations. Well, in about a day, people had trained this bot to be racist, to be sexist, to be really just a terrible person. I mean, it was awful. It said terrible, terrible things, and they had to take it down. And this is because artificial intelligence doesn't have context, right? It doesn't know that being racist is bad. It just knows whatever people were telling it, and it was learning from that, and it was learning very quickly. So one of the biggest gaps in artificial intelligence right now is that layer of context. We are so much better at context. We are so much better at switching conversations, at having multiple streams of thought. AI is very singularly focused right now. So there's no general AI today. We're very, very far away from that. A subset of AI, and something we'll be focusing on a lot in this program, machine learning. Machine learning are the algorithms behind AI. They take in massive amounts of data. And when I say massive, I mean potentially billions of records. So massive amounts of data. And they learn patterns and make predictions. Machine learning has really been the driving force behind AI, behind the ability to use Alexa or Siri or Google Now. Very advanced, there are both simple models all the way to very, very advanced machine learning models. But the constants are they need a lot of data. The more data, the better. They can only predict the future based on what's happened in the past. So for example, when COVID-19 happened, all of our machine learning models stopped working. They had no idea what to do. They had never seen information like this before. But they can find patterns that humans have no ability to find. So much, much better at pattern identification than humans are. And the last one here, the bottom, the smallest circle, is deep learning. Deep learning is a subset of machine learning, and it's used for unstructured data. We'll talk about unstructured and structured data today. Put very briefly, the difference is structured data fits into a table, like in Excel. Unstructured data is everything else. Tweets, photos, videos, the Facebook feed, all unstructured data. Very powerful, very hard to work with. And to wrap it all up, both artificial intelligence and machine learning require big data to work. It's reliant on having these massive amounts of data to make accurate predictions. And generally speaking, this is good news. Many of our organizations have lots of data. And once we figure out how to pull it all together and get it set up right, we can take advantage of these techniques, make really big changes for our organization. I like to talk about the data science process, and we'll anchor the course on this process because we'll cover basically every step here. So let me walk through this briefly, and I'll talk about why it's important. when most people hear machine learning, they think about the models that you can build, the predictive models. And if you follow this, if you're familiar at all with some of those models, XGBoost or decision trees or logistic regression, that's what gets data scientists excited. But it's actually only a very small piece of analytics, of data science, right? It's just one step. It's this analyze step at the bottom here. Everything else still has to happen. I say that good data science projects always start by defining a good business problem. Otherwise, you end up doing science experiments. And I've seen this before. At the last bank I worked at, when we were just standing up our first data science team, we hired all of these data scientists. And I remember talking to one data scientist who was going through all of our credit card data. Remember, we have 10 million customers, so many, many credit cards. And he said that with all of this information, he could predict how old our customers were very, very accurately. Okay, that's kind of interesting. Well, it turns out that when you apply for a credit card here, we ask you how old you are. So we already knew the answer. He spent months building a model to predict something we already knew. Not useful at all. You just wasted time, wasted data, wasted resources. So if you don't start with a problem that you're trying to solve, a real business problem, the analytics doesn't matter. You can do all the machine learning in the world, it won't matter. And this is, I think, the #1 most important thing for students in the MMA, because you are going to be the bridge between analytics and business. You are going to have to define that business problem. And then once you've learned the analytical techniques, figure out how to apply those techniques to the business problem. Discover and explore on the right-hand side here. These are all about getting your data, understanding what's in your data, what's possible. Analyze, what we talked about. This is the machine learning. This is the predictive modeling, the analysis. And then on the left-hand side, this is what happens after you build your model. Now you need to go out and convince people that we should use machine learning. We should use this model. It's accurate enough. It's reliable enough. It's robust enough. And the last step here, operationalize. How do we make this real? So say you build a model to predict the next purchase your customer is going to make. Well, what do you do with that information? Do you send them an email and try and get them to buy it earlier? Do you do nothing at all with it? Is it for marketing? Is it for telling your factory how much to produce? Where are you going to send this information? I'll give you another example. We, at my last organization, bought a very expensive data science team. We spent millions of dollars bringing in people that were good at machine learning. And they built a model that would tell us if someone was going to buy a house in the next 3 months. And if they were, then we could go out and we could reach out to them and say, you should get a mortgage with us. Mortgages are very profitable for us. And so they spent about a year building this model. And it turned out to be very, very accurate. They were very good at predicting within 3 months if you were going to buy a house. And so we took that information, we took this list of customers who were going to buy a house in the next 3 months, brought it to our marketing team and said, you need to send out emails and mail and get in touch with these customers because they're going to buy a house and they could get a mortgage with us. And they said, that's going to take us 6 months to do. So come back in 6 months. He said, they'll have all bought houses. So there's no point in doing it if you're going to wait 6 months. They said, that's the process. That's what we do. So all of the work went to waste. And they had to completely change the marketing process so that the model would work. This is why operationalization is so important, because you need to think about who needs the output, who's going to use the insights, and how they're going to use it, when they're going to use it. This entire process is extraordinarily important for being successful at data science. There's so much more than just being able to write code in Python. And the reason I do this as a circle is because it never stops. You're going to do this once and you're going to get something into production and it's going to be working, and then something will change. You'll release new products. The market will change. Customer preferences will change. And when that happens, you might have to move back a few steps. Maybe rebuild a model, collect more data. Maybe you have a new problem completely. So it's a very circular cycle, and every step is important. Where I think that MMA students can provide the most value is on the define phase and communication and operationalization. I think they're the most important phases. And the analyze phase, the explore phase, certainly important. But I think it's fairly easy to hire people who are good at this, who are very, very technical, who spent their careers or their entire schooling on just getting good at Python. So find those people, have them build the models, make sure someone is doing the very important thinking here. Now, I think we've all spoken about this a little bit, and Mikhail even brought it up. It's how much time people spend doing data work. This is real data from my organization. We sent out a survey. On the left-hand side here is the current state from a couple of years ago, but it hasn't changed very much. These bottom two bars are data preparation and reporting. 55% of our data scientists' time is spent just looking at data. Only 15% was actually on analytics, was actually building models. And this is because data is messy, hard to find, needs to be cleaned, and it takes an awful long time to work through all that and understand how to get to that place. What we're aiming for is the exact opposite, where almost half of their time is spent on doing that insight development, building predictive models, and very, very little is spent on data. And the way you do that is by getting very good at data cleaning, data preparation, and recording what it takes to get there. Making sure that every time you do some data cleaning, everyone at your organization has access to that. Everyone knows what that clean set of data looks like. So this is just a little bit of background on why this material is so important and why we need to spend some time at the beginning of the MMA talking about dealing with messy data. Let me take a quick pause here. Are there any questions, comments? Does anyone have any experience at their organizations with something like this, with messy data?
I'm sorry, I have a question about the previous slide. What's the difference between the discover and the explore phase?
Discovery is more about finding what data is actually available. And explore is once you have the data, what can we get out of that data? So if you think about a very large organization, data might be scattered across departments, different systems. Discovery is going out and understanding what we have. And a lot of the times it's not enough, or it's in the wrong format, or you need to be able to join data from a bunch of different places together in order to make it work. That's what discovery is all about.
Okay, thanks.
Other questions, comments? Any experience with this at your own organizations, working with this really messy data, starting to get into analytics?
Yeah, I can comment on the next slide with my experience. I also work at the bank and I work at management reporting with expenses. And we always measure our work against these proportions. And for several years, we're trying to minimize this working with raw data and moving towards advanced analytics. And this year we introduced more powerful dashboards. And so we reduced this part of reporting considerably, and hope that we can invest in advanced analytics in inside developments in next year. So we'll see how it works with us. But now we really have resources for that, because we now don't have to do this endless PowerPoint reporting sheets, and can concentrate on some meaningful value for management.
Excellent. You are not alone in that at all. I talk to organizations all the time that are in the exact same position, where everyone's busy, data's messy. You feel like you could do so much more, so much better if you could just get out of this
Mapping and copy pasting.
Yes. So you are not alone. Some of the biggest companies in the world are still dealing with that, especially if it's a highly regulated organization like a bank or an insurance company. Very hard, very expensive. Thanks for sharing. All right, let's talk about types of data. Data comes in all different forms, levels of information. I want to talk about a few different ways we should be thinking about data. There are 4 types of data with respect to the amount of information they have. They're called nominal, ordinal, interval, and ratio. We'll talk about each of them. Nominal data is the simplest data, sometimes referred to as a binary or a Boolean value. These are categories. One category might be singled or married. Gives you one piece of information. The person is single, or the person lives in Canada. These have the least information available. Ordinal data adds a little bit more information. Now we have a rank built in. So if you think about a satisfaction survey, we often send out surveys to our customers asking, how was your experience? 5 is very good, 1 is very bad. So the rank is meaningful. 2 is better than 1, 3 is better than 2. But the differences between those values is not equal. If we think about that customer satisfaction survey, I think it's fairly easy to go from a 3 to a 4, but a 4 to a 5 is probably very hard. 5 is a truly phenomenal experience, whereas 4 is good. So the distance between them is not equal. Interval data adds a little bit more information again. Now the distance between those values have meaning. Think about measuring temperature. The difference between 1 degree Celsius and 2 degrees Celsius is meaningful. It's the same as the difference between 2 and 3 degrees Celsius. And then at the upper end, the most information, we have ratio data, where there's still meaning and there is an absolute 0. So think about, for example, your salary, anyone's salary. 0 is absolute 0. Can't go any lower than that. And then the difference between $1 and $2 is meaningful. Now, I like to think of these as broadly 2 categories: nominal and ordinal data, and then interval and ratio data. So nominal and ordinal on the left-hand side here, these are really ranking data. They're going to give you information in terms of what group someone belongs to, how satisfied a customer is on a scale of 1 to 5 or 1 to 10. And then interval and ratio, this is continuous data. It's the most useful data from a modeling perspective. This is what you want. This is someone's salary. This is how far they live away from your work. This is how much money they spent, how much a product costs. This has the most information and it's the most useful. One thing to note is that you can move from more information to less, but never the other way around. So if all you have is whether someone's single or married, you can't tell me anything else about them. But if you have information on whether they're single, married, divorced, too young to be married, you can go backwards and say single or married. So you can always go backwards, never forwards. And this means when you're thinking about data collection, you always want to lean on having more information because you can make that more information simpler. You can never make less information into something more. A quick aside, I'm going to go through all the theory of this, but then you'll see it when we actually work through some of the data today. So I'll make it real for you a little bit later. We'll talk about the theory now. Later, you'll see continuous values and ratio data, and that will have, it will bring all of this to life, I think, make it a little bit easier to understand. Okay, this is data as it relates to the level of information. There's also the way we organize data. Time is a really important characteristic in data. And there's 3 different ways we organize based on time. Type 1 is cross-sectional data. Cross-sectional data does not have a time dimension. So it's a point in time. It's data from today or yesterday. Cross-sectional data is what we're used to seeing in an Excel file, for example, where you have a couple columns and data in rows at a point in time. When you do have a time dimension, we call it time series data. This would be like looking at stock data, for example. If you looked at how much any stock was worth, you'd see every day or every minute a dollar value, time series data. Panel data combines the 2 of those things together. It's cross-sectional with a time component. So imagine you work for a retail store. If you had panel data, it might be all of the sales for that store for every day across every store. This, of course, has the most information. It's also the hardest to work with because there's so many extra pieces there. The moral of the story here is that there are different techniques depending on what type of data you have. So it's important to have a sense for this. For example, if you have time series data like stock data, you can't use traditional machine learning techniques. You have to use some that are specifically designed for time series data. We're not going to talk about time series models in this course, but you probably will a little bit later in the program. Most of what we do in this course will be on cross-sectional data. And sometimes we'll add a small time series component so I can show you a little bit of what that looks like. I think it's also worth thinking about how data is stored at your organization. And there's 2 different things to think about here. One is internal versus external data. It's exactly what it sounds like. Internal data is data that your organization owns, generates, records itself. So I work for a bank. Our internal data is customer transactions. When you buy something on your credit card, we record that information. It's personal information about our customers. We ask you where you live, what your email address is. That's internal data. External data is data that we purchase. So sometimes we buy data from the government. We buy statistical data to tell us about the demographics of Canada. Sometimes we buy data from other banks so we can learn more about our customers. Internal and external data are very different for a few key reasons. One is you have to buy external data and it's often expensive. So we try and focus on our internal data as much as possible. It's not only free, but it has a competitive advantage for us in that we're the only people who have it. And if you work for a bank like Maria or I, you would know that our data is very, very valuable because we know so much about our customers. And then there's structured versus unstructured data. Structured data is what we'll be focusing on in this course. It's data that fits neatly into a table that you can look at in Excel or look at very easily in Python. Unstructured data is everything else. This is free text, tweets, videos, pictures, audio files, recordings. Unstructured data requires special techniques to work with. And it's only fairly recently that we've been able to work with unstructured data. We haven't had fast enough computers or powerful enough computers to actually work through all this. It's very hard to work with, requires advanced techniques, can be very powerful, but very specialized. I'll give you an example. In all of our bank branches, we have cameras for security. But it turns out that we can actually use that live video to figure out how many people are in a branch. And that means we can estimate wait times, we can direct you to a different branch if one's very busy, things like that. Very difficult to do, very powerful. The last example here is any self-driving car. So if you see a Tesla doing its self-driving, all unstructured data, right? Lots of information coming in from radar, from cameras, etc. Trying to give that car information and then making predictions. The last thing I want to talk about as it relates to data is the source of data. So internal data can come from a variety of sources. I spoke about transaction records. So for example, you buy something on your credit card, we record that information and we know where you bought it, how much you spent, what kind of credit card you have, etc. But there are other types of data collection methods. You can ask for customer surveys. You can bring in focus groups. You can hire an expert. All sorts of other ways that data ends up in your organization. And it's important to think about the reliability of different sources of data. Transaction records, very reliable, very easy to use. Survey results, maybe not so much. I used to do some product design work, and we would often send out surveys to customers and ask questions like, if you had access to a product like this at this price, would you buy it? On a scale from 1 to 5, 5 meaning, yes, I would definitely buy it, and 1 meaning, no, I never would. Well, it turns out that people just lie on these surveys and they don't actually do what they tell you they will. So when we got 5 out of 5 on that question, we would reduce that by about 50% because it turns out that people lie on surveys. Really consider the reliability of the data coming in, depending on where it's coming from. And remember that if the data is not reliable or is questionable, you may have to think about other techniques you can use, or maybe simplifying models, pulling out different insights. That's all I want to say about that. I'm going to talk about Python next, but before I do that, let me take another pause. Any questions about data collection, anything from your own organizations that you wanted to share about this? Okay, Python. What is Python? Well, Python is actually a general purpose language. It's a general purpose programming language. It can do all sorts of things, including machine learning and analytics, but not only that. People use it for software development. They use it to design websites. They use it to automate computer tasks. So it's a very broad language. It just happens to be excellent for analytics. It's also what we call an object-oriented language. This is really important because it makes it very easy to use. An object-oriented language means that everything we do in Python gets stored to an object. It's been around for quite a while, since the 80s, but as analytics and machine learning got more popular, Python grew in popularity very, very quickly. And it's now the #1 most used programming language in the world. It's also named after a Monty Python skit. Not a very exciting namesake, but that's where Python came from. In terms of being object-oriented, what this means is that everything we save in Python, we can save to an object, and we can call this object anything we want. I'll show you what this means later, but it means really that we're going to have this list of objects we can work with. Objects could be data, they could be models, they could be graphs, like visualizations. And the really nice part about this is that every object has predefined properties. What this means practically is that when you save a chart, for example, as an object, Python knows it's a chart and it knows what to do with it. It makes it very easy to take objects and apply them in other places. It makes it very easy to organize your thinking in Python. To save something to an object in Python, we use the equal sign, this sign here. Of course, this means that it's not a mathematical equal sign. It's the sign that assigns objects. If you want a mathematical equal sign, you need to use 2 equal signs. Just a strange quirk of Python. Python also has a number of data types. These are how Python stores data. That's how it thinks about data. And they apply very closely to the data types we already spoke about. One of them is numbers. Those numbers fall into the categories we talked about earlier: nominal, ordinal, ratio, etc. They call them slightly different things. Integers, for example, are whole numbers. Floats are decimal places. Booleans are those categories, those 1 zeros, married or single. Practically, not so important. Python does a pretty good job of guessing what data type you have. So when you go and you import your data for the first time, Python takes a guess and says, I'm pretty sure this is a number. So it's going to store it as a number data type. There's also text. Of course, sometimes you store data as text. You might want to say that a person is married, and you would store that as married text. It is important to know that you cannot mix text and numbers. Python and every other programming language is always going to fall back on the most flexible data type. This is text. Text is the most flexible. You can include anything you want in a text field, but you can't do mathematical operations if there's text. This is for obvious reasons. A plus A doesn't equal anything. So if you have a cell with A1 in it, it's going to be text. You're not going to be able to do any math. The next 2 here, lists, sets, data frames. These are ways of storing groups of data. We're going to be working with data frames very often. A data frame is Python's way of describing a table of data. So when you open up Excel and you see all this data in rows and columns, that's a data frame. It's just the Python word for it. Anytime we come across a very strange data type that you haven't seen before, I'll explain it. For the most part, this all happens behind the scenes. I just wanted you to see some of these, so if you see them come up in Python, they're not surprising. I've got a few examples saved here of how different data types appear. So this first one is a string. This is short for string. And anything in quotes will end up as a string. Integer values are whole numbers. Floats are decimal numbers. And then down below, we have things like lists, Booleans, etc. These will make much more sense as we start working through these together in Python. This is just a reference guide for you. Most of what we're going to see are integers, floats, and strings. Sometimes Booleans. Everything else, for the most part, you're not really going to work with. Remember that because Python is a general purpose language, it includes features that you never need for analytics. Not all of these are going to be important every time. When we do our first Python demonstration, I'll show you how all of these look in Python, and we'll take a look. Okay, data exploration. This is the real heart of what we'll be focusing on today, and the last piece of content before we'll take a break and then do some live demonstrations. Why data exploration? Well, we've talked about this a little bit already. Corporate data is dirty, messy, and hard to get. Anyone who's done any work with data knows this is true. Unless you happen to work for a new company or a Facebook or a Google, corporate data is really hard to get. Whether you're getting it online, internally, lots can go wrong. Lots of work needs to go into making it ready to model. The second thing is, once we have data, we need to understand the limitations of that data. For example, if you only have 1 year of data on the sales of a product at your organization, well, that's not a lot to go off of, especially given how strange the last year has been for everyone. If you had 10 years of data, you'd have a lot more information about how different economic cycles or different seasons might impact those sales. So what are the limitations there? Number 3, dirty data will cause problems for your models. If it's not structured right, if you've missed something, if it's dirty, it's going to cause problems. The best case scenario is that you identify those problems and fix them. The worst case is that they don't show up in your testing. You make mistakes, you put something in production, and then this bad model starts running your business. The upfront data exploration work can save you lots of time and lots of money. For a bit of context here, at the banks in Canada, we actually have a specific team that reviews all of your work before you can use a model. And you have to submit to them where you got your data from, how you cleaned it, how you explored it, how you built your model. They review all of that, and they try and make sure that you caught all of those problems, that you're not going to put something into production that doesn't work. So here are the 8 stages of data exploration. These are just my 8 stages. These are ones I really like. You will, of course, find other ones if you go looking, but I think this is a good start. We're going to talk about the first 4 today, and I'll show you how to do a little bit of this. And then as we go through the course, I'll show you how to work through 5 through 8. I'll tell you what they are, but they require a little bit more information before they'll make a lot of sense. So we'll talk about each of them in detail. But briefly right now, variable identification. What information is in your data set? What does each column mean? Data structuring. Is the data in the proper form to build a model, to build a visualization, to get insight out of it? Univariate and bivariate analysis. This is when you first start pulling insights out, either one variable at a time or multiple variables at a time. We'll talk about why that's important. Missing values. Lots of data will have missing information. What do you do about that? How do you fill that data in? Outliers. This is data that you don't see very often. For example, if one of us in the class was a billionaire, that would be an outlier, right? Someone who's very much unlike the rest of us. Outliers can have big implications for models. Variable transformation. This is modifying your variables into the right format. So perhaps you have text data that you need to become a number or something like that. And the last one, feature engineering. This is taking your data and modifying it to create more useful information. A few definitions for us here. You'll hear me sometimes talk about features, variables, etc. A feature or a variable is just a piece of information in your data. It's a column in your data. So a feature might be how old someone is, how much money they make, where they live, whether they're married. Those are all features. They're information about a person. A target variable, or the target, is what we're interested in predicting. These are also sometimes called your X variable for features and your Y variable for your target. So you'll see all of those used interchangeably, and we'll see them often. They will come back up again. Okay, a few examples. Variable identification. I know it sounds almost too simple. What does this variable mean? But in my experience, the variable names are completely unintelligible, very hard to interpret. This is from our data warehouse at work. I really don't know what most of these mean. These are actual feature names from our data warehouse. A big part of that discovery phase at finding data is understanding what the data actually is. And that requires good metadata, which is data about data. The best case scenario is that you get a bit of a dictionary that tells you exactly what these columns represent. They may also give you information like, what's the range of the data? What's the highest value and the lowest value? What are appropriate values for the data? What are their data types? How should you use this data? When was it last updated? All very, very important information, and sometimes really hard to come by. The story I like to tell here is we once worked with a very big consulting firm that liked doing data science work. And they came in, they were working with our wealth management division. These are the people who manage investments for all of our customers. And this consulting firm came in, collected all this information, and went away and said, I'm going to build you a model that predicts who is going to leave the bank, who's going to take all of their money and go to another bank. And they didn't ask for a data dictionary. They didn't ask for any useful information. Came back a few weeks later, presented their model and said, yeah, we've got this great model. It's very accurate at predicting who's going to leave the bank. And they were going through all the variables they used. They said, this is this really important variable. And it turns out that whenever this variable is a 1 and not a 0, this person leaves the bank. So what is that? It turned out it was the variable for the customer having died. Not really a useful predictive model. It turns out that once you die, you can no longer be a customer. So variable identification is actually quite important. It's important to get those data dictionaries to understand what's going on in your data. A few things to consider here. Are there duplicate values? What do special characters mean? Sometimes you'll find that there are random special characters in a data set that mean something very specific. You'll see that in one of the exercises we do later today. Data structuring. In order for your data to be ready for modeling, it needs to be what we call tidy. Tidy data has 3 characteristics. Each variable has its own column. Each observation has its own row. And each value is in its own cell. This image here shows a tidy data set on the right-hand side. And I know it looks bigger, longer, but all of the values that we care about are in a single column. And this is what's most important. Think about if you were trying to make a visualization in Excel and you wanted access to all of those values. Well, it'd be really hard if they were spread across multiple columns, hard to access. So when building a predictive model, you can only give that model a single target feature. In this left-hand example, there is no single target feature. It's spread across 3 columns, 1, 2, and 3. So we reformat it, we put it all in a single column, and that lets us use a predictive model here very effectively. You'll know that your data is not tidy if you can't find a single column that you're interested in, if that one column is spread across many columns. I'll show you an example of this later today. I'll make it a little bit more real. Univariate analysis. This is really about understanding each variable individually. So these are running statistics that you're probably already familiar with, like the average, the most frequent value, the median. What are the maximums and minimums? I really like histograms and box plots for this. So this is a histogram of a company's advertising budget. We can see all of the most frequent values here. Looks like a very normal histogram to me. This is going to give you information about big outliers. It's going to give you information about whether your data is heavily skewed in one direction or another. Very important to understand all of your variables individually. And then, of course, understanding your variables together. How do variables interact with one another? What's the correlation between variables? The most common bivariate analysis is correlation or a scatter plot. So the standard scatter plot chart, a great way of looking at how 2 variables interact with one another. This is really important because univariate analysis, single variable analysis, doesn't tell the whole story. This is why. So here we have 12 scatter plots. They have an X variable and a Y variable. And those X and Y variables have the exact same characteristics, the same summary statistics. So X and Y have the same average, the same standard deviation, but it turns out that they look completely different. They even managed to make a little dinosaur with the same characteristics. So each little piece can be a little bit misleading, right? The average of a data set can be misleading if there are big outliers. The mean the standard deviation could be misleading. It's only until you start putting all of these pieces together that you get this whole picture of your data set. We're going to cover the rest of these data exploration techniques in later classes when we have a little bit more background to work with, when we have a little bit more Python ability, but I promise I'll go through all of those. That is all I have for PowerPoint content today. I want to pause here and see if there are any questions about any of this, anything else we'd like to talk about or share. I see a question in the chat here around data cleaning tools. So there are some very specific data cleaning tools. For example, Trifacta is built around data cleaning. We're not going to cover any of those because they're proprietary. What we're going to do instead is focus on the techniques in Python. And there are specific packages that we'll use to do that. Those techniques that you learn in Python are broadly applicable. So if you end up with whatever software tool at your organization later, whether it's Trifacta or Alteryx or some other predictive modeling tool, you'll follow the same steps. They'll be called the same things. You'll just have to do it in their particular format. So I'm trying to stay away from the proprietary. We're going to go all open source for this. That way, no matter where you go, where you work, you'll be able to use these tools. The trifectas, the Alteryx of the world, they're very expensive. Even Tableau, for example, I think Tableau here might be over $2,000 a person to have. So I tend to stick with the free tools, especially if you're very early in your data science journey as an organization. Much easier to get support with inexpensive tools than saying we need to spend hundreds of thousands of dollars on something. And then we will talk more about how to tell when your data is in fact clean. So we'll work through that entire process together, all those 8 steps. And if you go through those 8 steps, you can be reasonably certain your data is clean. From there, we'll talk about how a predictive model, like a regression, can give you even more information about whether your data is clean or not. Any other questions or comments? Feel free to throw them in the chat or come off mute. Okay, fair enough. Well, I have been talking for almost an hour now, so I'm going to propose we take a 10-minute break. We'll meet back here in 10 minutes, and then we'll jump right into Python, and I'll show you a few examples of what we just talked about. We'll see you in 10 minutes. Old versions to make things work. It's not going to happen for us. This here, this text input field, this is where you're actually going to write your code. Once you've written code in there, you can run it and see the output. And up here are all the buttons we need to use to interact with Jupyter Notebook. So this button allows you to save a notebook, which you're going to want to do very frequently. Make sure you save your codes. You can go back and reference it later. This button here allows us to add new cells. We can add as many as we need. These allow us to write new pieces of code. So you can write many, many pieces of code in the same notebook. Keep everything nice and organized. The cut button removes cells. And this button here allows us to copy and paste them. So if you have a cell that has a big piece of code you want to reuse, just copy it, paste it, and it will keep pasting down. You can also reorganize these. So if we call this cell 1, we can move it down and around. So you can reorganize your thinking here. You can reorganize your code. Now, one of the best things about Jupyter Notebook is it allows you to do more than just write code. So in this drop-down menu here, we have a few different options. Code is the default, and it's exactly what it sounds like. It's where you write code. But if you wanted to organize this or make it really easy to work with, you might change it to heading. And it's going to give you this little warning here, but it allows you to do nicely formatted text as well. So you can have headings. Markdown is the option for text. And you can actually have full paragraphs, full written information in here mixed in among the code. This is really, really valuable because it allows you to leave yourself notes, interpret outputs. If you're sharing this with other people on your team or other people in your organization, it allows you to leave context there for them. So really, really valuable to be able to do this. All you need to do is click on this dropdown and change it. I hardly ever use the fourth one, the raw option. I stick with markdown and headings. Very easy to use, very easy to work with. These buttons in the middle here are exactly what they sound like. Run runs that line of code. The stop button will stop anything from happening. So if you accidentally write some code that's going really badly, that's stuck in a loop, you can just click the stop button and it will stop. Restart, pretty similar. It will stop and start the whole thing. And this button here will restart it, but it will rerun every line of code. You don't want to use that one unless you really know what you're doing. Stick with the single lines for now. Up at the very top, we can give our notebook a name. So we'll call this class 1 demo. And now it's saved in a place that we can work with. You will sometimes see this screen. This is a sort of file browser built into Jupyter. And you can see here, I have all of the cheat sheets for the class. And I have a folder with all of the data we're going to be using for these cheat sheets as well. To create a new Jupyter notebook, you just click on this new button here and ask for a new Python 3 notebook. And it will open up that blank notebook we're used to seeing. My advice is play around with this a little bit. You really can't break it. Play around, open new notebooks, get comfortable with it. The best way to get comfortable is to play around, write some code, open new things. I will show you a few examples here. When we break into our teams, highly recommend that you work through all 3 of the cheat sheets from today, even what I'm going to show you, because it does take some time to get familiar with this. You'll remember earlier we spoke about Python being object-oriented. Here's what object-oriented means. We can create a new object, and we're just going to call it object. You can see that the colors change as we type things. This is meant to give you a little bit of extra information. You'll see how these colors correspond back to objects or specific syntax. Now, unfortunately, I am colorblind, so I don't actually know what the colors are, but I know that they change. And you will learn what the colors are and what they mean. All I can tell you is that they change. I apologize for that. If you remember, when we spoke about objects, we said that objects could be numbers or text. So let's start with some text here. And we'll just say that an object that we call object is equal to the text hello. We can click the run button, and you'll see that this changed a little bit. It gave us some information, and it moved us on to the next line. What we've done now is we've created an object with the text hello. So if I wanted to see that, I could say to Python, please print my object. And if I type run, it knows to print the word hello. So Python remembers every object you give it. Now I can go in here and I can change that, and I can say, hello class. I can run that. And when I go back to print the object, it's now changed. I can also make an object, we'll call it Alex. We'll say Alex is equal to 5. So Python is now going to know that the object Alex is 5. So now I could print Alex and get 5, but I could also ask Python to do some math on that. I could say, what's Alex plus Alex? Well, that's 10, or Alex multiplied by Alex is 25. You can store as many objects as you need to with any options you want. We sometimes call these variables, right? You know, the variable named Alex. And of course, Python knows exactly what to do, right? So if I went in here and I said, well, can you give me object plus object? Remember, object is hello class. When I go and run that, it's going to put them together. It's just going to append those 2 strings. If I go in and I ask to multiply the 2 of them, wow, then I get an error because you can't multiply text. So Python knows what you've saved, and it's going to tell you what's going on here. What this error says is you can't multiply non-integers. So we see this last year type string. It's basically telling us the multiply operator does not work for strings. You can't use it. Now, you're going to get a lot of errors when you first start programming because Python's very particular about things. It's case sensitive. for example. So you need to make sure your lowercase, your uppercase letters are fine. Things are going to go wrong. It's going to give you errors. Sometimes the errors are very helpful, like this one, can't multiply strings. Other times the errors are going to be really hard to interpret. And that's part of what makes this really frustrating. If you're getting errors that you can't read, while we're in class, just ask for my help. I'll come and I can normally help you figure it out. Otherwise, send me an email, copy and paste your code and the error in it, and I'll help you troubleshoot that. It's going to be a little bit frustrating to start, but stick with the code that I've given you, and it's going to be a little bit easier that way. Now, of course, objects can have multiple items to them. So while this object we've created here is a single string of hello class, we might want to reference just pieces of that. So say we only wanted the first character from this. We just wanted to see that capital H. Well, we could tell Python that we want to see object. And then if we use square brackets and a number, it will return certain pieces of a string. So this is what we call an index. This allows us to reference specific pieces of an object. And this becomes really important when we talk about data frames, because data frames will have columns. And sometimes you'll only want to see specific columns from a data frame. We use that exact same syntax. And so as we cycle through here, object 1 is going to give us E. Object 2 is going to give us L. One important note here is that Python always starts counting at 0. It does not start counting as 1. So the first value in Python is always 0. Then it goes to 1. We can also ask for a series of values. So in this case, I want all of the characters from position 0 to position 5, and it's going to print out hello for me. To do that, we use this colon indicator in the middle here. Now, a big part of using Python is using the packages that come with it. So there's a whole bunch of packages that exist in Anaconda, exist outside Anaconda, that we'll be using throughout the course that make our lives with Python much easier. Python runs in your computer's memory. So it's very fast, but that means every time you start Python, every time you open a new notebook, it doesn't remember anything that happened before. That means every time you open Python, you need to reload your libraries. This is a little bit inconvenient because it means that every time you want to create a chart, for example, you need to import the library to make charts. But this is actually a good thing because you don't want Python having to load dozens of libraries every time it turns on. It would be very, very slow. So we get to be very selective with Python, and we only import the libraries we need to accomplish what we want. I'll show you how we can import libraries. It's very easy, and there are some that are built right in. For example, there is a library in Python called math. And in the math library, there's a bunch of mathematical functions. If we want to use the math library, we type import math, and we run that. And you'll see it ran, nothing really appeared to happen, but now we can reference functions in the math library. And to do that, we type math, period, and then a function from the math library. I happen to know in the math library that there is the sine function. And we can pass a value to sine like 1, and it will calculate the sine of 1. This is just a basic trigonometric function. It's a very simple example. We can, of course, use cos as well and get another trigonometric answer. This pattern exists for every library. Every library we download will follow the same pattern. We're going to import a library, in this case math, and we're going to reference the functions within that library. all of the libraries have excellent documentation online. So if you went into Google and you searched for Python math, you would get a page with all of the math functionality. And it would give you examples for how to use it and what to do with it. There are, of course, also libraries that are not installed by default in Anaconda. Most of what we're going to be using is going to be installed by default. But if it is not, you need to write a little bit of code to install them. And I'll show you how to do that. If you're on a Mac, you need to use Terminal. And if you're on Windows, you need to open the command prompt from Anaconda. Now, I can't show you the Windows one, but I can show you what it looks like on Mac. Basically, you're going to, let me show you Terminal. You're going to open up Terminal. You're going to get a screen that looks like this. And you're going to type the words conda install, and then the name of the package you'd like. It's the exact same on Windows, except you're going to do it in the command prompt. Now, my packages are already installed, so I am not going to run this. But if you wanted to install a package, for example, NumPy, that's what you'd write. You hit enter, and it will install the package automatically. It will be immediately available to you. You can go back to your Jupyter notebook and run it right away. I will tell you. Yes. Yes, so in Windows, let me go back to Anaconda. So in Windows, you will have an extra box here that says command prompt or something similar. You just launch that and run the same code. Now, this is available. You don't have to remember this. In cheat sheet 1, I've got this for you. This code is available to you in cheat sheet 1, so you don't have to remember it. Open up cheat sheet 1, you'll see a bunch of information there on how to work with this. Yes, thank you, Vladimir. No. I understand there's a question from Elena. Could you come off mute and I can try and help you out? Oh, okay. Got it. Yes. Libraries are, for the most part, open source. And that means that it's just groups of data scientists around the world that create these together. Some libraries are produced by very large organizations. So, for example, a very popular machine learning library is called PyTorch. Google created that. And they make it available for everyone to use. They use it all the time at their organization as well. So these are all just big libraries available online. People discover that they want to do something in Python that isn't currently possible, and they write a way to do it and they share it with the entire community. That's one of the greatest things about open source languages like Python and R is there's a community of data scientists around the world that make it really easy to use and continue to make it better. I would say that the most common libraries are created by Google, by Facebook, companies like that. And then there are a bunch of smaller custom ones built by data scientists around the world. You can, I will show you a bunch of these libraries as we go through the course. As you become better at this and want to work with more libraries, you can tell how good a library is if you go to their GitHub page. I will put that in the chat. GitHub is a place where people can share things like this, share libraries, share code, and it has a star system. So you'll go in there, you'll see PyTorch, for example, or scikit-learn have thousands and thousands of stars, which means they're very reliable, they're highly used, they're easy to use. So you can always rely on that system to know if the library is any good. And they all install the same way. It's always this conda install library. yes, I will definitely do an example with a column. The next thing I'd like to show you is how we start working with some real data in Jupyter. Right now, we've just been sort of creating objects and playing around a little bit, but we should also import some real data and work with that. So on the portal, I've shared some data sets that go along with these. The first one I'm going to use is what I call the grocery store data. This is data that I've created myself, and you might imagine it being data about a local grocery store. So how much people have spent on their groceries, how far away they live, how many cars they have, how big the family is, information like that. To import data, we need to use a new package. This is one of the most common libraries in Python. It's called pandas, like the animal. And of course, to do that, we need to import it. So we're going to say import pandas. And what you'll find is that people use shorthand for these packages all the time. So if you write import package name as, you can write whatever text you want, and it will remember that as the name. Data scientists always import pandas as PD. It's just what everyone does. I don't really know why. That's what we do. So we always import pandas as PD. We're also going to import one more package called OS. OS is a package that's going to allow us to talk to our computer directory very easily. Now, don't be intimidated by these lines of code, because you're just going to copy and paste these every time. You don't actually need to memorize this. Just copy and paste it. It works the same way every time. We're going to do one last thing, and I'm going to show you how to import a very specific piece of a package. Some of these packages are very large, lots of things going on in them. We can use the command from to reference a very specific part of a package. So I'm going to say from os.path import curdir. This is short for current directory. And all it is a reference to wherever this Jupyter notebook is saved. When you think about the file structure on your computer, you have to save this Jupyter notebook somewhere, and you have to save data somewhere. And you need to line those things up so that Jupyter knows where to import the data from. Unfortunately, it all has to be done with code. There's no easy way to do this with a click and drop. A couple of questions in the chat here that I want to cover. So question one, how do we know that third-party companies aren't going to steal our data or anything like this? Everything you do in Python is local to your computer. So it doesn't go to the internet or anything like that unless you specifically ask it to. Now, there may be malicious packages out there. So stick to the big ones, stick to the well-known ones. And unless you're going to be using a computer on the cloud or something like that, a computer on the internet, you don't really have to worry about your data being stolen. These are enterprise-grade tools. Big banks use them. It all stays local on your computer. There are a few other messages in the chat here. Dimitri, could you help me with that? So you'll get used to a set of very standard packages. There are maybe 5 that you'll use all the time, and you'll hardly ever have to go beyond those. If you do have to go beyond them, if you're looking for something very specific, most people rely on GitHub. If you search Google, Stack Exchange and GitHub are great places to find both code and packages for Python to solve very specific problems. I'll give you a bunch of the very common packages that every data scientist uses. We're going to do our first one right now with pandas. We'll also do some other ones like stats models, NumPy, very, very common packages and have probably 95% of what you're going to need. Yeah, so to understand which package to import, you have to think through a little bit of what you'd like to accomplish. For example, right now, I want to import data. I know, and you'll start to remember, that for importing data, pandas is the best way to go. So anytime you're going to import data, you're going to import pandas. If, for example, you wanted to build a fancy machine learning model, you would learn that sklearn, scikit-learn is the place to go. And that's, again, a specific package. The good news is there aren't very many of them. So you'll start to remember very quickly that import data's pandas, machine learning, scikit-learn, visualization, matplotlib. You just start to learn these. And then what we'll do is we'll save them in our Jupyter notebooks, and you can reference them. So you always know all of the packages you need and all of the pieces from those packages. I know this looks a little bit intimidating because there's a lot of code going on here, but let me tell you, even the best programmers just copy and paste everything. Even the best programmers Google for the answers. No one memorizes all of this. So use my cheat sheets, copy and paste the code from there. It will work very, very easily for you. If you copy the code exactly, structure them the same way, it will just work. That's what everyone relies on. Okay, so okay, for anyone having technical challenges getting into Jupyter or Anaconda, let's save those for now. And when we do the team breakouts, I'll come and visit and try and help you troubleshoot one-on-one. Very hard to troubleshoot if I can't see what's happening on your screen. It looks like there's a couple other questions in here. So you can always enter code one line at a time in a new cell every time. You can always do that. That's fine. The one thing to remember is that if you're looking for some sort of output, so say, in this line 20 right here, we wanted to know what the cos of 1 was. A cell will only output one piece of information. So I could go in a single cell, I could import math. I could say I want to create an object called calculation is equal to math.cos1, and I could print calculation. That will all work. And all it's going to output is that one line. If I asked it to print out 3 things, not going to happen. So one piece of output per cell. That's the rule. So that's one chart, one analysis. You can do as much as you want in a cell in terms of importing libraries, in terms of calculations, all of that, but one output, one print.
What does this figures and brackets mean? 5, 6, 7, 17, 21, in 5, in 6, in 7, what's that?
Those are the cell numbers. If you remember early on, I added and deleted a bunch. So I deleted cells 1, 2, and 3. So if I go down here and I add another one, you'll see that it has blanks now. But as soon as I run it, we get a star to say I'm thinking, and then a number for the cell number. It's a way to mark in, code in, and output. So in 20, out 20 is code in, output out. This is really handy because I'll be going through this and I'll say, take a look at cell 21 where we've got an important line of code. So it's a way to reference back to what's going on.
Thanks.
Mhm. Yeah, so for anyone with technical problems who can't get Jupyter working, when we break out into our teams, I'll come visit and we'll figure it out. Question in the chat. Yes, Jupyter Notebook is available on iPad. It's actually pretty good. I don't mind using it. I think it's best on a computer where you have a little bit more power. But yes, Jupyter Notebook is available for the iPad, and it works fairly well there. Are there any more questions in the chat that I should work through? Okay, excellent. Okay, so if we take a look at cell 22 here, in 22, where I've got my mouse, those are the 3 lines of code to import the packages you'll need to get data into Python. We then need 2 extra lines of code. So one is we're going to create an object called file path. You can call this whatever you want. I call mine file path. And this is going to tell Python where our data is saved. All of my data is saved in a folder called data in the same directory as all of my Python workbooks. So here's my data here. Here's the grocery data that I was talking about. I recommend you organize your data in the same way. So wherever you save your Python notebook, create a new folder called data and save your data there. This works really nicely because then we can always reuse this line of code. The line of code looks like os.path. That's this right here. .join. Join is going to let us take a few different pieces, put them all together. Current directory from here. So that's where we're currently saving our Jupyter Notebook, wherever you saved it and opened it. Data for that folder I showed you where I store my data. And the name of the file. In this case, the name of the file is MMA 860 grocery data.csv. And you need to use that whole file name, including what comes after the period. You need to make sure that's all there. Now this block of code right here can be copied and pasted. And as long as you have the data folder, all you need to do is change this name. So if we didn't have the grocery data and we had some other data, that's all you need to change. And this will work every time. Now, all this does is it saves an object called file path that is the location of our data file. The last line of code we need is actually importing that data set itself. For that, we're going to name our data. I'm going to call mine grocery_df. df is short for data frame. We're going to use that equal sign to assign an object. And we're going to ask for a function from pandas. Pandas is PD. Open it there. PD dot read_CSV. That's the really important line. So CSV is a file extension. It stands for comma separated values. It's a very common data format. It's a very common way to store data. Most of the data we work with in this course will either be a CSV or an Excel file. And I'll show you how to import both. Once we have that, we can open a bracket and say we want to import file path. If I run this line of code, I'm just going to click run up here. For any of you who like keyboard shortcuts on a Mac, the shortcut is Command Return to run the cell. And on a Windows, I believe it's Control Enter. So I can run that. We can see that it went to a star quickly and then changed. And now we have an object called grocery_df. Why don't we just go ahead and print that so we can all take a look. So here's our data set when it's printed out. We can see that we have some information on the grocery bill, on family income, family size. What this has done here is it said this data is way too big to print all of. It would take pages and pages to print it all because there's 1,000 rows. So it just shows us the top 5 and bottom 5 records. That's all. But of course, we can look at whatever pieces of this we want to very easily. Now, there are additional pieces to importing a file that might be important. We call extra pieces of information in a line of code arguments. Arguments are generally divided by a comma. And an argument gives Python information about what's happening. So in this line of code here, cell 23, line 6, all we've said to Python is read in this CSV, read it in exactly the way that it's saved. We could give extra information to Python. So we could say something like header. Header would be that very first line of data. We could say header is equal to false. And this would tell Python that our data does not have a header. So it's all data. It doesn't have these column names like grocery bill or number of adults. This is really important because if you get this wrong, it might record data as a column header or vice versa, a column header as data. There's also an argument called index column, index_call. So if you have a column like I do here called observation, this is really just a way of counting which row you're on. It's not real data. It's just a counter. We can reference something like that and say our index column is observation. And when I run this and reprint, you'll see that we've now turned observation into our index. We don't have that extra column over to the left-hand side anymore. There's a few things going on in the chat I want to address. One is, will we do this in groups? Yes, highly recommend that you run through this in groups. Work through the cheat sheets, and I'll give you instructions when we're done. I'm nearly done working through some of this before we break away. Dimitri, I think there's a few other things I may have missed in there. Well, if there are questions, I will address them all before we break. So if you're in Canvas, for example, and you go to download a piece of data, sometimes by default, it will just go to, say, a downloads folder on your computer. Just Oh, so how to take data from Jupyter and output it. So I do that all, I save all of my data in a file explorer. So on a Mac, I open up Finder, and I will go into Finder and find the folder I care about. So for this one, I look at my Python cheat sheets folder, and I just create a new folder there called data, and Anaconda will find that. So these are all just folder structures on my computer that I then point Jupyter at. Jupyter doesn't actually create them. No, not really. I mean, there are technical limitations, but there are not practical limitations to how much data or how many cells you can have in a Jupyter notebook. Modern computers are very, very powerful. Data is fairly easy to store. If you start working at enterprise scale and are working with terabytes of data, then you can't do it on your laptop. But otherwise, you're hardly ever going to run into a limitation until you get into very advanced predictive modeling. No, so when you import a piece of data, like the grocery data file, it gets imported exactly as it's saved. So if you opened this data up in Excel, for example, it would look exactly like this in the same order. When you break into groups and work through the data exploration work, I'll show you how to sort data. So you can rearrange it by income or rearrange it by family size, whatever you'd like. But there's no default behavior for sorting. It's just however the data already exists, that's how you're going to get it. There are a few things that are worth showing you as part of Pandas. So I want to show you two more things as part of importing data. The first is that for this particular line, we used read_CSV. Sometimes you're going to want to import an Excel file. And when you want to import Excel, you can't use read.csv. You need to use read_Excel. That's the only difference. You otherwise line it up the exact same. Make sure that this is an Excel file in your location, and then you just change this to read_Excel instead of CSV. One caveat to this is that Excel files can have multiple sheets in them. Right? A CSV file only has one table in it, but an Excel file, you can have multiple sheets. Sometimes you're going to need to reference which sheet you want to import. And to do that, you use an argument or a parameter called sheet name. And you just give it the number of the sheet you want to import, starting with 0. So 0 would be sheet 1, 1 would be sheet 2, 2 would be sheet 3. Again, this is saved in the Python cheat sheet 2 importing data. So all of this is available for you. All of the code is there. You just need to copy and paste it and arrange it correctly. And the second thing I want to show you is that Pandas has a bunch of great tools for looking at your data. So when I printed this out, not a very useful view of data, right? It's cut off all the middle records. We see the top 5, the bottom 5. There are probably 4 Pandas tools that are very, very useful. One is the head tool. So grocery_df is our data frame. If we add a period and we say, I want the head, it will print us a nicely formatted table with the first 5 records. Much nicer than this here. We can also change that to be as many records as we want. So maybe we want 10 records. There's 10 records. The opposite of head is tail. That's going to give us our bottom 10 records. Very nice way to see a nicely formatted table, however many records we want to see. I recommend sticking with a small number like 5 or 10. So there's no reason to print out 50 or 100 records. There's also the describe function. And describe is really, really useful. When we run describe, it gives us all of our summary statistics for every variable, which is great. So in here, we can see our average, our standard deviation, the smallest value, the largest value. These 3 lines here represent the first, second, and third quartiles. So the value, if you line them all up in order, what's the value a quarter of the way up, halfway up, 3/4 of the way up? Really, really handy tool here. Gives you lots of great information about your data, can help you identify some data challenges. For example, if you're seeing averages that don't make sense or maximums that don't make sense in here, it's going to call it out to you right away. Very handy tool, very great way to get to know your data. And the last one is D-types. D-types will tell us what type of data object each column is. So we see here, almost everything is int64, is short for an integer. This is a whole value, which is just fine. Like I said, Python normally guesses these correctly, does a pretty good job at importing data here. You'll see, and this will happen as you work through the data exploration cheat sheet, sometimes Python gets it wrong. So for example, grocery bill has been saved as an object and not a number. And that's because there's a $sign in the data, and a $sign isn't a number. So Python incorrectly saved this as text, and we're going to have to fix that. We'll come back to that. That is importing data. In sum, what I would remember here is this is the most important bit of code from importing data. You're always going to need the pandas package to do this. So you can always import pandas. I really like this style of the path join, where you can say current directory, data folder, whatever data file you need. And then line 6 here, this is where you're actually doing that importing. A few of you had some questions around how do we get this file structure working. So let me just show you how I've organized this. You'll have to excuse my file structure and how messy it is, but what I have is a folder here called cheat sheets, and I'm just in Finder. I'm in the folder I use for all of our class material. You can see all of my cheat sheets here. So we just went through intro to Python, importing data, and all I've done is I've created a folder here. Right-click new folder. I've created one called data, and I save all of my data here. So when I download new data files, I just save them right here, so that this line of code that I showed you always works. That's how I organize. You can organize however you'd like, as long as you know where your data is saved. It's going to be very easy to import. Okay, I know that's a lot. I know it's intimidating the first time you get started, but I promise it will get easier. When I first started coding, I was very frustrated. I smashed a lot of keyboards. I recommend you get a couple keyboards you don't really like, some old ones. After a little while, you can get nicer keyboards because you won't be so frustrated at this. But I promise it gets better. The first time's the hardest. It gets easier every step of the way. What I'm going to propose now is that we have about an hour left together. I'm going to propose we break into our teams very soon. And when we break into teams, let's do a few things. One, let's make sure everyone has Anaconda and Jupyter working. So if you don't have it working, put your hand up right away. I'll come visit. we'll get it working. 2, work through the 3 cheat sheets saved on Canvas. They are called Python cheat sheet 1, Intro to Python, 2, Importing Data, and 3, Data Exploration. If you save the data the way I showed you in that data folder, all of the code will work. So what I recommend you do is run the code that I've written and then try and type it yourself. Play with that code a little bit, change a few things, create your own Jupyter notebook, and play around with it. Work your way through those 3 cheat sheets. If you have time, there's an exercise saved on the portal called the exercise 1. It uses some real survey data from a survey a university did here in Canada. And there's a few steps that you can work through to clean up that data a little bit, produce some visualizations, etc. The next time we get together, I'll walk you through these as well. So you can see how I would approach it. I'll share my code with you. So you'll see exactly how I approach everything. There's a question in the chat here. How do we save the cheat sheets in Windows? If they are currently in your downloads folder, just copy and paste them to wherever you like to save your course material. I'd recommend you start a folder called, acquisition and management of data or something like that. And then perhaps save a cheat sheets folder, save them all in there, make sure you have the data to go along with it. And I will give a double check on the portal to make sure that everything you need is there, but I think we are all good. I think we need to, I'll work with Margarita in just a moment. I think we need to upload 2 data sets there for you, but we can do that right now. Okay, before we break into our teams, and I'll come visit all of the teams once, are there any other questions, comments, anything else we should talk about? All right, I am positive you will all have questions soon. So there's lots to work through here. But in that case, I will come visit all the teams. I recommend that everyone takes a 5 or 10 minute break when you get into teams. Just, it's been a lot, have a tea, take a little break, and then we will see you all soon. When you're done, if you've worked through all the exercises, if everything's done, feel free to leave. We are not going to bring everyone back at the end of the evening. So use this time however you see fit. If you're 30 minutes in, you're smashing your keyboard, you're tired, you're cranky, don't feel like you need to stay. I want this to be effective for you. So use it as wisely as you can. I see someone with their hand up. Go ahead.
Да, у меня iPad Pro, хотел бы скачать Юпитер, но что-то не получается.
I think the app you need is called CarNets. I'm going to put a, I'll put a link in the chat for you. I think that is what you want.
CarNets получилось, да, запустить на iPad Pro.
Excellent. It looks like there's a couple things in the chat. Is there anything? Okay. Excellent. Okay, Margarita, do you think we could get our breakout rooms going?
Actually, they're already done, so I can just open the breakout.
Excellent. Please do. We will talk to you all soon. I just sent you a few data files, Margarita. Could we just post those on Canvas?